Good afternoon. It's 1300 on the East Coast. It's 1700 on the Zulu Coast. And welcome to PFG Live. Almost Machining, welcome aboard. Mr. Blodgett, welcome aboard. CJ Stevens, welcome aboard. Warren Jones, my neighbor, welcome aboard. Is it more noon eve? More evening after something? I don't know. It's we're here though. How many of you had to use computers to figure out what time it was? I know I did. But thank goodness, I don't even know. No, actually, there's a mechanical clock in the shop that runs my coolant pump. So that's now off by an hour. There's a few mechanical things around. Evan, welcome aboard. Nice to see you. So, once again, you guys bring the good luck. It's Sunday. It's a severe clear day here in southern New Hampshire. Temperature 44 degrees, or so I'm told. What a beautiful day. If I sound a little weird today, it's because I think I have a little cold, but I won't let that stop us. So how are you all doing today? So in news that doesn't matter, I'm checking out this new Yeti mug with their newfangled latching mechanism. And so far, jury's out. Not sure. Honestly, I wanted to like it more, but I don't. And we could talk about that later. So let's see. Let's get some weather reports going here. Location and temperature, please. And if there's any precipitation. Warren, I know you're fabulous. I've been watching your line boring videos, and they're not that boring. I know you scored a save recently on something that didn't quite come out right, and then you fixed it and made it better. And I'll just remind you all that Julia Child always said, "You're always alone in the kitchen." Magnetic, so you can clean it. Yeah, okay, so you know what I'm talking about. That is true. You can take it apart, you can clean it. That's not the part I don't like. I'll talk about that in a few minutes. I don't like the design of the drinking hole, okay? Plus, there's no explicit vent. So those two things kind of make it a little less pleasant to use, right? CJ Stevens reports low 40s and wet in East Tennessee. There's a lot of east to Tennessee, isn't there? Warren says we're about the same temperature here. Well, yeah, that's because you're about, 20 minutes away? But good to hear. So, let's see. We got a bunch of stuff on the docket today. I've teased you with some discussion of cylinder squares. Somebody brought that up last week, and I don't remember. I can't give credit for it, but somebody brought up the topic of cylinder squares. And it's actually a topic I enjoy discussing. So I spent some serious thinking time, and I will share that with you, and we have some surprises coming up. So there is some shop news we'll get to in a minute. Let everybody get checked in. Mr. Blodgett reports 40s and cloudy on Whidbey Island, Washington. Of course, that was redundant. MAB Machine reports 34 in central Ohio. Outstanding. I have some friends in roughly central Ohio, but they don't check in. They don't come watch. I'm a little sad. Anyway, so we have a little bit of shop news. If you've been following me on Instagram, you know that I was hunting for a cutoff tool. And the cutoff tool story was was pretty significant because it shouldn't be this hard. It shouldn't be this hard. So I've been using a Sandvik tool. I didn't bring up the Sandvik tool. I've been using a Sandvik tool, which I guess it gets the name monoblock. So it's a tool with a square shank. It gets a special carbide bit. Almost Machining says, I will be making cylinder squares in the near future, some made to order. Excellent. I like that idea because I think it can be done really well. And it's a fundamental, well, we'll get into it. I'm a little overly excited about the whole cylinder square thing. So where was I? Yeah. So here's the story. One of my followers on Instagram who became a viewer here sent me. He's actually local, and forgive me if I don't identify him. But he sent me this bar of titanium. So this is approximately 2-inch diameter. It's actually a tad over 2-inch diameter titanium. And he said, can you slice this up for me into, see it right here, into 3/16 inch slices? And of course, what do I know? I said, sure, no problem, of course. Yeah, so the saw blade that I tried to do that with was unhappy. So we got about halfway through it, and the saw blade said, I'm not doing this anymore. Which was no surprise, by the way. I get it. So I checked my available tools, and the available cutoff tool I had, because I figured I'd go to the lathe, which is much stiffer than the saw, and I would use a cutoff tool. And I could only go to 1 inch with the tooling I had. I can go deeper, but with very thin tooling, which was not going to touch it. So I went on. I said, well, I'll just go buy a better cutoff tool. And this did not go well. This was not easy. It should be easy. Now here's the problem. I've got a V35 TC from Dorian Tool, which is my tool post on the Haas TL1. And I have been using this Sandvik tool in a regular boring tool holder that goes on the tool post. So I went looking for something that will be able to do the 2 inches, and I couldn't really come up with anything acceptable until finally I hit it hard in the last few weeks, and many of you were very helpful. I put a post on Instagram. Many of you were very helpful about getting me some recommendations. And you'd think that, okay, I picked a recommendation, now I can go buy it. It should be easy. It was not easy. And finding a guy that, a tool dealer, a tooling dealer who knows their tooling is not easy. It wasn't, I had a hard time. I even checked with some of my old standbys, and I struck out. Finally, I called a local dealer here down in Lowell, Industrial Tool Supply, and they've always been very good to me. And finally, going around and around a couple of times, we settled on a solution which was recommended by the group, and that was this ISCAR tool, which is called an F-Tang, I think you call it. All right. Let's I think we have a photo of this up here. Hang on. Let's see. Yep, there's a photo. I'll turn that on. Let's get out of studio mode here. There you go. So this is the tool we came up with. So this is a new tool, pretty neat, okay. And it's sort of looks like a letter F. It's 3 millimeters wide, which is one of the requirements for getting my cut as long as I wanted it. And we found a kit. The guys down at Industrial Tool Supply found me the kit, which is everything you see right here. So 10 of the cutting tools plus the bar life is good. Hey, Carl is just checking in. Hi, Carl. Welcome aboard. So, also in this kit is this wonderful widget, which goes into the hole here and acts to, let's see if we get that, acts to help you insert the tool, or you move it down to the other hole, right, and it helps you remove the tool, which I'm not going to do. So we got that far, and I was actually pretty excited about it because many of you folks said you were loving this tool. So then then I go on to the Dorian website. Now, Dorian doesn't have a very good website for ordering. They have PDFs of their catalog. Little behind the times. So I have to go through my dealer anyway. So I fish up the tool number, double check, cross check, all that good stuff. And this is what shows up this is what shows up in my delivery box yesterday. Okay? And if you're saying to yourself, that's no tool holder, that's no Moon, okay? You'd be absolutely right. I have no idea what this is, but this is not what I ordered. So I have to go back and sort that out. I do have another tool holder. I might be able to lash something up to get this thing working, but I kind of want to get what I ordered. So we're halfway there. This is a familiar theme. We're halfway to getting that cutoff tool. Will you have the insert facing up or down? I think it'll be traditional. I think it'll be facing up. Okay, and that's because of the forces. We want the forces to be going that way. And by the way, if you think about the TL1, there's no compound, right? Because it's a CNC lathe. It is a stiff boy. I'll tell you what. It is very stout. So I'm not too worried about the stiffness of the lathe. Yeah, Warren says he likes the way the insert is seated in the holder. It's pretty cool. So I'm really looking forward to trying it and getting that going, and I will of course make a video and give you a full report. But amongst the things I have to get done is slice up this titanium as a favor. And then I actually have a couple of projects for the shop where I'm going to be working with 2-inch stock. Actually, the finished product that I have in mind is 1.5 inches, I think. But same. So that's the news in cutoff tools. I also have let's see what else is going on. So if you guys have any specific cutoff tool comments, I'm interested to hear about it. But that was one of the shop successes for the week, or at least one of the pieces of progress. So we're getting closer. Do any of you find it easy? Oh, I need a cutoff tool that'll do blah, and you pick up the phone or you go to your website, say order, and you're done. Does anybody find that that's easy? Because it's not my first rodeo, and it was a pain in the neck. Let's see. A quick thank you to a supporter. You know who you are. I got a secret squirrel, which is up on the board here. I thought I'd give you a little close-up. Thank you for the secret squirrel. It's not a sticker, but it's on the sticker board. So thank you very much. Let's see. What else is going on? In the rotary attachment department, I got the rotary attachment for the Epilogue laser. Hang on, I got a cough. Let's hear it from mute buttons. So the Epilogue laser comes with 2 rotary attachments. I shouldn't say comes with. It makes available 2 rotary attachments. One of them looks like a little lathe. I'm looking for a picture for you here. Come on. I know we took pictures of it. There we go. No, yes, no. Wow, I don't have pictures of it for you. I'm falling down on the job. So one of them is it looks like a lathe, okay, and one of them is called a rim drive, and it's designed to. It has two sets of rollers, and it just rolls a cylinder for laser marking. That's the one I got. I got the rim drive. The other one has a 3-jaw chuck. So the rim drive, I successfully marked some of my tea containers as an experiment. I did another container for another friend of mine, a travel mug. So that's all good. But I have for this project that's upcoming, I need to laser mark on the rim of a disc-shaped thing. Okay, so imagine a disc, and around the rim of the disc, I'm going to have an engraving from the laser. So I came up with a way to, I could basically make fixtures to hold my thing and put it in the rim attachment, let that drive, and then the thing I'm marking will be on the end on a fixture, and I could mark on the rim. So that's what's coming up. I'm pretty excited about it. I think it's going to work out really well. So that's all working. So it wasn't smooth. I got it installed. I started marking one of the T-Mug things, and I was not getting things to work the way I wanted to. And you know, when you're doing something for somebody else, you get one shot at it, and if you screw it up, it's broken. You can't repair it. So this was powder coat on stainless steel. So I looked up the recipe, and I got everything sorted out, brought the graphics in from Adobe Illustrator into the laser printer driver, and it wasn't behaving right. I hadn't hit print yet. I was doing the trace the outline of the thing you're about to print, and that didn't look right. So I get on the phone to Epilogue Laser. They're in Coresville. They're in Golden, Colorado. And they were super nice. And we finally got to the conclusion that I was back a couple of versions of software. So they said, do a software update for your printer driver, do a software update, a firmware update on the machine. I did, long story short, did both of those things. Everything started behaving, got the job done. So rotary laser attachment, working great. In other news, this is a little bit of nerd ham radio news because some of you are hams. I'm starting to look at a little radio, and I'm interested to hear if anybody has any experience with this. This is the ICOM 705, which is a little tiny box. In fact, when I was at I went at the ham radio outlet, and I took one of their I said, "Do you have a brochure?" And the guy looked at me funny, like, "You want a brochure? You don't know how to use the interwebs?" So he gives me this brochure, and what I did is I folded it up to be the size of the radio. Okay, so at least these two surfaces here, right, the top and the front, was the size of the radio. Hey, Henry, welcome aboard, sir. So this is literally the size of the radio. It's that big, and it's this deep. And then I started holding this thing around in the truck to see where this thing would fit. So I won't get into a lot of depth on this, but it's a HF, UHF, VHF radio, maximum 10 watts out, cute as heck, and it'll even run on a battery, on a built-in battery. So that was an investigation. So I'd be interested in hear if anybody has any experience with that, and we will get to that. So that was another thing we did this week. Henry, how's the weather? And how's the time? Did you figure out what time it is? The United States moved. Mr. Simpson's here. Time change. I tried. I really tried. I made the mistake also when I posted. And I apologize. And yeah, it's probably going to affect, our live viewers, but we'll all get caught up. So just for future, on the time change, it will remain at 1300 Eastern time. So whatever that means to you, that's what it means. And I figured out that it's 1700 Zulu. Right, Henry? Did I get that right? Should be 1719 right now. UTC Zulu. All right. So moving on. recent posts in Instagram. I want to thank Adam Balog of Laney Machine Tech. He's working on his Fizzo interferometer, and it looks very exciting. So if you're not following Laney Machine Tech, you really ought to, because he's got some really cool stuff happening, and looking forward to see that. It's 11C there in Germany. You're in Germany now? Are you back from your travels? Or did I get that wrong again? Can't keep track of you, sir. So, before we get into our major topics, I think that's all the news. Definitely go check out Laney Machine Tech and the Fizzo interferometer. You may have seen my last posts on lapping. I'll give you a lapping update. Were that I successfully reversed my my lap curvature. So you may recall when I first made the laps. Okay, Henry, thank you. I get confused. When I first made my laps, I did the initial run-in of the lap, of the working lap. Of the conditioning lap on top of the working lap. And unfortunately, I ran that, I conditioned for too long, and I should have been checking it as I was going, and I wasn't. That was an error. Because I don't know how fast these things go. So when I was all done, I ended up with a very convex working lap, which was generating concave work pieces once I started lapping my work pieces. And they were measurable and visible on the inspection with the optical flat. So I flipped the conditioning the conditioning lap on top of the working lap, and I started working it to get that curve to reverse. And I did. So I was able to show by measurement that the parts were now had flipped the other way. That was my goal, was to go through zero, right? And see it the other way, and then start working my way back to flat. So that's where I'm at right now. I have not gotten back to it's very flat. It's not perfectly flat. And next thing I'm going to focus on, and I don't have anything to report specifically yet, is the technique, because I don't think I really have a handle on the lapping technique. Robin talked about it. Tom Lipton talked about it on our discussions. So that's the next thing I'm going to focus on. I'm very pleased that I feel like I can control the laps now, and that's a win. So stand by. We'll get back to that. Yeah, and we'll have some more lapping news. But overall, very happy with the progress. So I think that's everything in news. And if you guys have any news, please put it in the chat and we'll talk about it. So today, the topics, we got a couple of topics, and we had a couple of questions come in. So let me take them in reverse order. So we're going to take the off topic items first, and then we will zero in on our topic of the day, which has to do with, of course, cylinder squares. So Henry says he's got himself a new project too. He bought a 70,000 RPM air spindle for internal grinding. That sounds really cool. I am hoping for pictures and excellent results. So, Henry, what diameter ID do you anticipate working on? Because 70,000 is pretty impressive. So I'm guessing we're in the 1 centimeter range. Is that correct, or are we going a little bigger than that? And are you proud of me that I went all metric on you right there? That sounds really cool. I'm looking forward to pictures. So here's a topic that came up that I want to address is, would anybody be interested in an audio-only version of this uh, PFG Live on a podcast channel in which we would just take the audio and we would put it out as a separate podcast? Would that help anybody, or is that not useful? That's my question for you. So what I have done is I've signed up for an Apple podcast account. So we sort of have the spigot ready to go. And then I would have to do some work to just translate the audio portion of the PFG Lives into podcasts. And it's a matter of convenience. Because I think most of what we do is transmitted on audio. And there's a little bit on the PFG Lives that we do in graphics or video. Let me know what you think. I'm interested to hear your feedback. So I got another good question today. Let me give credit where credit is due, and specifically, let's see, where is he? Evan asks. I'm going to read his question. Evan wants to buy a Speedio. And I can't blame him because it looks like a really cool machine. And he wants to make his Speedio make money. So his question is, how do I buy how much did he say it was going to be? $80,000 to $100,000 machine and justify it by having itself pay for itself. And he didn't specifically say this, but by making and selling a product. So he has a couple of ways. Actually, he did specifically say that. So Panos says, very useful. This is with respect to the podcast idea. Very useful while working in the shop, battery-wise, and also not having to stop the audio every time you do something else on the phone. Greetings from Greece, by the way. Welcome aboard, sir. Nice to hear from you. Okay. It won't take too many positive responses to get me to do this. It'll take a little time for me to sort out the mechanism for how to push that. You got to love it live, right? Okay, so continue the feedback. I appreciate it. So Evan wants to have his Speedio pay for itself. And this is a really good question. Because he could provide a service or he could provide a product. Oh, he's here. Evan says, I should say I'm a hobbyist looking to justify having one, not as a full-time business. Very important point. And I have some opinions. Okay, Warren is providing the thumbs down on the podcast. He said it might be interesting and helpful. However, I would never listen unless I was in the car for a long time. Working in customers' shops does not lend itself to podcasts all that well. It's a good point. Okay, so Evan brings up this question. So I think I was in the similar position in that I always wanted to buy toys also. My excuse was that I was and am an antenna consultant. We don't talk about that a lot, but I got a funny feeling one day we're going to be talking more about it. And I used my machine shop to make prototypes. So that led to me investing in machines. And you can make the argument that the work I did paid for the machines, which it did, but there was a couple of links in that chain. Then later, when I started making PFG Stones, available at pfgstones.com, I started a business which made a product, and that justified purchasing a a grinder, and that took off. So what do? I like the idea of making a product and selling the product. However, making and selling a product has less to do with making the product than it does marketing. And I don't mean marketing from the standpoint of slick advertising or, running ads or, doing the podcast circuit. I mean finding a need and filling it, which sounds almost cliche, but it really is true. You brought up, Evan, in our conversation, you brought up a couple of markets, and we talked about the ham radio market, physics, scientific instruments market, and the I'm going to use the word toy market, but really I mean fidget spinners. Remember fidget spinners? So you have to find a need and fill it. And sometimes that's not obvious. What I've done is I've made things that I wanted, right? And then I talk about it, and all of a sudden somebody raises their hand and says, "Hey, I want one of those." And the way it worked with PFG Stones was I published a picture of the PFG Stones that I had developed, and the tray, my trademark red tray, and I just posted a picture of it, said, "Hey, here's what I did." And 7 guys came to me and said, "Are you selling those?" Now, when 7 people ask you if you're selling them, what is the correct answer? Yes, I am. So that literally is how that started. So you were there other things that I've made in the past that nobody was interested in? Many. Okay. So you have to recognize when opportunity strikes. Another cliche, but it's true. So the best advice I can give you out of all of that noise is do what you're interested in doing, do what you love, and if you make a thing, find people who want to buy your thing, but you have to be sensitive to that. It's also easy to miss it, to miss the signs that you have a product you can sell. Okay? So there's risk involved. You're going to lay out, $80,000 to $100,000 because you want the toy. That's a risk. But on the other hand, you're not going to have a whole bunch of business lined up to justify the toy unless you have the thing made. So solving that problem is not trivial. And Robert Simpson says, "That's how I ordered my 4-inch stones." Thank you very much. Yeah. Don't forget the thumb. I missed it. I missed the thumb. I'm sorry. And you'll have to explain the thumb because I'm forgetting it. So that's my opinion. My opinion is if you want the machine now and you think you're a creative enough person to come up with something that your Speedio can make and sell and then pay for the Speedio, fine. But you have risk. Hey, Rob Renz is here. Welcome aboard, sir. Thank you for being here. We haven't gotten to the extreme technical stuff yet. We're about to do. I think we're going to wrap up this topic. So that's it. Decide if you want to take the risk, and then go buy the machine and trust yourself to make this happen. Great YouTube content. As far as don't forget, yeah, K-Bonk says, don't forget the thumbs up and the like and the subscribe. as far as what market to attack, again, it's the thing that you are most interested in. So for me, it was learning machine shop stuff. I mean, I was just digging it, and the surface grinder was the pinnacle for me of oh, I'm going to learn this and get good at it, and then that converged with a market saying to me, hey, I'm interested in that, and that's how it worked. So there you go. I think I'm excited for you. I like the Speedio. So one of the things about the Speedio is you can make parts fast, which means you can make parts, small parts, relatively inexpensively. So you're sort of figuring out, okay, it's a thing that's going to be about this big. What's it going to be? I don't know, but if you keep thinking about it, it will show up on the horizon. And if anybody else has comments on that, please put it in the chat. So then I get a call from, not a call, I get a message. This is going to lead us into our topic for today. I get a message from my buddy, the Machine Shop. What's his full? Hang on. Anyway, I don't know if you're here. Are you here? He runs a lab down at a university, a little technical school on the Charles River down in Cambridge. And he was just thinking about how do you scrape in an angle, right? Because he was thinking of projects for students. And we talked about how you scrape in an angle. And what I said to him was, and this is something you could chime in on, Robin, I believe from the way I was taught is that you would scrape in one surface of the angle. Do I have an angle here? Yeah, I have something that'll serve the purpose. All right. This is a bit of a small item, but this is not quite an angle plate, but this will serve to illustrate. So what I would do is I would scrape in, one surface and make a nice flat surface. And then I would measure. I would start measuring for perpendicular on this surface and marking it. And then start scraping that in by, step scraping. I couldn't remember the term. By step scraping until this was basically where I wanted it. And then I'd scrape in this surface for flat. And then measure again and correct and measure and correct. So it's not for the faint of heart. It's not a super simple project. In fact, when I took my scraping course with Richard King that was taught at John Saunders' shop, those many years ago, it's got to be 6 years ago. I don't remember. I actually bought and brought with me a couple of pieces, and I thought one of them was an angle plate, and I thought the angle plate was going to be my project. But actually, I never got past I brought a straight edge, a cast straight edge. That ended up being my project, and I never got to the angle plate. And I didn't understand why that was the more complicated, very much more complicated part until later. But that would be the next project. So that's a little complicated. But what do we mean when we talk about a right angle, right? What's so hard about, a right angle? Well, we've talked about generating flat from fundamentals. You have nothing, right? And Robin actually did this. I'm glad you're in the chat. Robin took 3 surface plates, and this is, by the way, covered in the more special tools book, Fundamentals of Precision. And if you execute the Whitworth method, well, what is the Whitworth method? The Whitworth method is you take a plate, you label it plate A, and you mark plate A on plate B, and now you scrape plate B. Okay, so you take off the high spots. Now you take B and you mark C, and you scrape plate C. And now you take C and you mark A, and you scrape plate A. And as you go around that cycle, you are getting to flat on all 3 surfaces. And you could convince yourself that you don't need anything else to get to flat using that method. Thank you, Robin. Foundations of Mechanical Accuracy. By the way, that book is still purchasable from More Special Tool, and it's $150. When I bought it, it was $150. Totally worth it. Okay. And in the interest of full disclosure, I actually found a PDF. Thanks, guys. I appreciate it. Yeah, I knew I was kind of fuzzy on that. I found a PDF online, and then I bought the book because it was well worth the money, and we want to encourage that sort of thing. So get that book and read it. And we're going to be touching on a lot of what came out of that book today. So the Whitworth method allows you to auto-generate a flat surface. This is super important in the whole world of accuracy. So the Egyptians and their subcontractors built the pyramids, and Whitworth was not even around yet. Yeah, Robin says the pictures are worth $150. Totally true. You may recall that I bought and showed off this Moore rotary table that came out of the Apollo program at MIT, and we actually found the pictures in that book of the room where they scraped in the Moore rotary tables, and it was awesome. MAB Machine reports it's $190 plus shipping and handling now. Totally worth it. Okay, so you can use the Whitworth method and start from nothing and auto-generate a flat. Okay, kind of the next thing you need to do is figuring out how to get a right angle. So the Egyptians built the pyramids, and their subcontractors built the pyramids, and they didn't have a surface plate. You know what they used? Who knows what they used for flat? How do you measure flat? When you're building a pyramid. I'm delaying because of the lag here, but this is actually a pretty important point, and it is actually useful for what we're talking about, and Adam Balog has talked about it also. Thank you, Robin. Robin was the first one. Water. So they had these trenches of water around the pyramid they were building, and as long as the wind wasn't blowing and it was steady, the surface of that water, and of course you're going to average it. There you go, man. MS Live also got it. That surface of water was the flat reference, right? And then you can pick off of that flat reference and go do your other stuff. But the next thing you need is this right angle, okay? So there's a bunch of ways to get there, but let's just do thought experiments to see if we could arrive at the same thing. When I bought these Windy Hill Foundry angles, yes, flat and locally level. Good words. So the Windy Hill Foundry levels. By the way, these are awesome castings. He does a great job. Look up Windy Hill Foundry. So I bought two of them, and you can argue that if I have two angles, right, I could check them against each other. The problem is, and I think you see where we're going with this, what if the two angles had the same error? So now really you need three of them. So if you had three items that you were trying to make right angles out of, you could use the Whitworth method because you've already solved the problem of flat. So now you have a flat surface. You take a right angle-y thing and you check it against another right angle-y thing. And you do the same thing. You mark it, you figure out what adjustment you have to make. So you have A marks B, B marks C. Yeah, Robin says, still off by the curvature of the earth. So it's funny you should say that. I'm actually interested in I have a laser surveying transit, also known as a theodolite, and I am led to believe that the curvature of the earth is measurable over the span of a football field, and like like really well, like really easily using that equipment. So I think one of these days we're going to do that, and this should be a lot of fun. So you could use the Whitworth method to go from A to B, market, adjusted, B to C, C to A, go around that circle, and you end up with 3 right angles. So that's another way to get to that right angle. Is that the most fundamental right angle? Or, as we've been led to believe, is a cylinder square. Okay, this is a Brown and Sharp model 558 cylinder square. Is a cylinder square the fundamental source of right angle? So what is a cylinder square? Let me turn on a picture here. This will give you a little bit of eye candy. A cylinder square sits on a surface plate and serves as a reference. It has some really cool properties. And let's talk about this a little bit. Oh, what just happened? I lost my picture. I got kicked off my own library. Please stand by while I fix the slideshow here. That was funny. Come on. Sign in. So the cylinder square has some really super cool properties, and it's actually pretty straightforward for you to make one of these. And this is ground and hard and precision and magnificent, but really, what if you reach into your pile of stuff and you come up with a piece of scrap? So I'll point out that Tom Lipton did a few videos on cylinder squares, and his objective was to be able to make an inexpensive but highly accurate. Kevin Blodgett says, "I'm told it's hip to be square." It is, and round. So Tom Lipton did some videos on basically a McMaster car-based cylinder square that starts with a piece of, I believe it was piston material. There's a name for that. Somebody help me with that. And really, that's what you need. So this is a piece of not terribly impressive. I think this is 4142, and it's literally just a cutoff that was in the shop. I clearly was doing something fancy on this end. Actually, I think I was making a cylinder square, and I aborted it. I don't remember exactly what was going on here. But let's say you had a lathe, and you chucked up a piece of stock in your lathe, and you turned a cylinder on it, right? And now, actually, Warren, what do you call that material that you use in the hydraulic cylinders that you can buy? Adam Booth uses it all the time, and I just can't remember the name of it, which is already chrome plated and very high tolerance, but still reasonably inexpensive. Put that in the chat for me, would you? So you have a lathe, and you're going to turn a piece of material. Yeah, Thompson shaft is one of them, but there's some other name for the hydraulic cylinder stuff, and I don't remember what it is. So Thompson shaft is an example. How would you proceed to start to make a cylinder square? So you turn your material, and the first thing, Warren says induction hardened chrome rod. Okay, that sounds like a generic term for it. So you turn yourself a cylinder on your lathe, and now you get out an instrument called calipers. Now, I don't mean measuring tool, Mitutoyo calipers. I mean literally the calipers that you could set to a certain size and then compare your calipers to the cylinder. Robin says, scrape or lap the edges of a square plate is the easiest and can be checked with an optical flat for flatness of the faces. So that's pretty cool. So Robin is saying take a square plate, right? So take a piece of plate and then work on these edges, and that gets you quickly to a solution. And Robin also says piston wrist pin. That's a good idea. In fact, that was just, well, we'll get to that later. So any of these materials that you can get that are already really close to what you want and isn't going to require a heck of a lot. But you could also turn it on the lathe. You could take a comparator, a caliper, and check for cylindricity, right? And what if you're turning something on the lathe and it's not coming out perfectly cylindrical? It's starting to get a little cone shaped. You know how to deal with that. You can offset, you could hold it with your tailstock, offset your tailstock, and eventually get yourself to the point where you have a good cylinder. And that's really step one, is I have a good cylinder. So that's pretty straightforward. The next thing is, how do I get the face right? So you're still in the lathe and you're turning your cylinder and you face the end of your cylinder. Well, what if your axes are off? You're going to get either a dished face or a crowned face because of your compound, your cross slide not being perpendicular, right? Because you're depending on the lathe. It doesn't matter. So you want it to be dished, and you absolutely don't want it to be crowned. So you can go in there and do your cut. You can compare it. You can go over to your surface plate and see, did I get a flat surface when I did that facing operation on the lathe? What does Brown and Sharp do? Right? Brown and Sharp dishes the end of the cylinder square so that the periphery is left. See the recess here? Now think about this. If you dished the end of that rod so that you had a periphery, some little land on the periphery, and it was a little crowned, does it matter? Not that much. If it was dished, does it matter? Not that much. So that's why that's done, is to reduce the errors, to manage those errors. So once you do that on the lathe, you lop off this part, and now you stick it on your surface plate. Okay. What if how do you manage the errors? All of engineering is managing errors, because there's always errors, and all we do is manage them. So now you go over and you observe what the errors are. How do you do that? Well, there's a few ways to do that. This device right here is called an indicator square, I think is the proper term. This one happens to be a Taft Pierce indicator square. So this looks like a indicator holder, right? But it's not. It's just a beautiful base with a beautiful ground finish and all that kind of stuff, and this here indicator. And I can measure the cylinder square. And then what do? Well, I go around the other side of the cylinder square, or of the cylinder, and I measure it. And if I go and I measure with my indicator square on both sides and they're equal, then it's square. And if it's not equal, it's leaning. So now what happens? I march around my cylinder, right? Do this mentally. I march around my cylinder until I find two sides that are equal. That will always happen. You will always find two sides that are equal. That's a minor lie, but a small one. And when you find those two sides, you found square, even on an unsquare cylinder. Think about that. Somewhere around the cylinder square, even if it's leaning, because the bottom is not quite in line, you're going to find two opposite sides that are square. So now you have a measurement that will let you adjust that until it's square all around. Do you need to? It depends on how critical the work you're doing is. So the point is that you can get to this reference for perpendicularity without a lot of technology. And you can get to this reference without any technology. You can use the Whitworth method. So I want to show you one that I made recently, and I hope you like it, because I think it's something everybody could reproduce in their shop, and it won't take terribly long. And I will be posting a video on how I made this, and I think you'll like it. So first, you need a piece of stable material. You know, what's more stable than a piece of 2x4? And the first thing you need to do is put 3 screws in the bottom. What does that get you? That gets you 3 points of contact. What does 3 points define? It defines a plane. Once you've done that, you can go up on one side of it and put 2 more screws. That gets you 2 points of contact. What does that define? That defines a line. Okay. And now you could put this down on your plate, and you could bump this up against something and make a measurement. Now, if you make 3 of these, now I know it's expensive. I'm sensitive to the costs here, okay? But if you made 3 of these, you could execute the Whitworth method and have A work against B, B work against C, and go around that loop. And when it's all done, you'd have 3 squares that are very accurate. Right? So, and by the way, these are hardened surfaces. Make no mistake about it. These drywall screws that I used are hardened surfaces. I'm reminded of there's a gentleman by the name of Jones. I don't remember his first name. I'm sorry. Who is a telescope mirror guy, and he's actually an optics professional. And one of the funniest things, well, funny to me, but it's very practical, that he does is he teaches people how to make telescope mirrors with just junk. And he made a spherometer out of a piece of wood and 4 drywall screws. And it was just absolutely hysterical. So I'll see if I could find a link to that video. But that sort of inspired me to make my version of the high precision square. By the way, this is adjustable. So let's think this through. So if you're going to make this, you're going to make A, you're going to make B, you're going to make C. Yes. So Robin is bringing up the second order issues, and I'm glad you did. So Robin says that cylinder square measurement method can be influenced by probe tip shape and rest edge shape if not square from all angles. Here's what Robin means, and I'll tell you why Robin is right and why I disagree. So the way this indicator square works is, you see this guy has a foot down here that you bump up against the part, and you'll notice that it's curved in both directions, right? So that when you bump up against the part, it's a point contact. That's important. Also, the tip of this indicator is also a spheroid, so it has a point contact. And if you don't have point contacts, you're going to get an error, and that's going to be an error in that measurement. So in my PFG square, you'll note that the contact points are not spheroid, and they may not provide a good contact. My point is that you manage the errors, right? So if you manage those errors, and you know that's a problem, We're not going to be building any hypersonic aircraft using this tool. However, if you put the screws in at an angle, right, and you get the curve of the screw, you can get back to that point source, and it's not bad. Okay, I didn't do that in this particular version, but that's a good point. So I think we're gonna have Rev B of this, which is the Robrand's modification on the PFG tree bark square. So anyway, build 3 of these, right? And here's the procedure. You bring A up to B, and you see which top or bottom has a gap, right? Now you take out half that error by turning the screw. Now you go B against C, and you measure it, and you see which top or bottom has a gap, and then you make the adjustment on C to take out the error. Now you make C on A, right? And you see which one has the gap, and you adjust A to take out the error. So you go around that loop a few times, and you will have 3 excellent accuracy squares, and it didn't cost you $1 million. So I hope you'll appreciate the humor here, but in fact, it's teaching you sort of what's important as far as making that right angle reference. And as far as the cylinder square is concerned, it's a similar thing, except you're starting with a lathe, right? So you're starting with the ability to turn on the lathe. Robin says point contact is not the issue. It's the lean in the opposite directions from the 2 sides that can cause the possibility of error. Okay, so what Robin's saying is these 2 screws have to be adjusted for square so that these do their job properly. And I get that. Okay. What my point is that if that isn't perfect, the contribution to error is relatively small compared to the contribution of error to error of the other adjustments. So you make a tool that gets you closer to a better tool, which gets you closer to a better tool, which gets you closer to a better tool. So your point is absolutely taken. I will say one more thing about this model 558 from Brown and Sharp, which is that actually, if you read the bottom of it, it says max tilt. It's like, what the heck? Well, this thing actually has, it goes this way. If you put this side down on the surface plate, this thing is intentionally tilted. And then they give you these markings. Let's see if you can see the markings. They give you these markings around the cylinder such that you rotate the cylinder square until you get a blackout fit with your part, which looks like this. All right, you put your part up there, and when you get that blackout fit, you then read the numbers on top of the cylinder square, and that is the number of tenths in 6 inches out from square that you just measured. So Brown and Sharp did something magnificent in that they took that tilt and they turned it into a tool. And that is wicked cool. Oh, yeah, Robin says he's talking about the cylinder square measurement only. That's true. So, you make an assumption with a cylinder square that you're measuring on this line, and if you tilt that line, then you start not measuring exactly on the, what would we call that? We'd call that the tangent line of the cylinder. Again, absolutely true. It's an error. You manage that error. So you could get close, and then you can get closer later. But I think it's so cool that Brown and Sharp took that error and turned it into a measurement tool. And that's what makes this particular tool pretty unique. So, in summary, I think you're able in the shop to make yourself a pretty decent cylinder square on the lathe, or from the 2x4, and then have something that's a pretty good reference, and you can do it from fundamentals without a measurement instrument. Let me say that again. You could do it from fundamentals without a measurement instrument, without something that refers back to inches or meters. What if the error in, so this is Sleeping Saloon, what if the error in your cylinder square is that it's a cone? That is an error, because now it depends where on the cylinder square you're making your measurement. Yeah, Robin says, then it's not a cylinder. Correct. When you're turning your cylinder or grinding your cylinder and you go in with your calipers, right? I'm not measuring per se. I'm just comparing. It's a comparator. I'm going down my cylinder, and if the numbers are all the same, then it's a cylinder. If the numbers are not the same, it's not a cylinder, and you have to correct until you get a cylinder. That's what makes a cylinder square a cylinder. So you can't not have it be cylindrical, but you can determine cylindricity without a special tool. Well, I hope you enjoyed this deep dive into the whole question of getting to right angles. I think it's kind of fun, and I was literally going to make my own out of the 4142 stock until I found this Brown and Sharp. Well, thanks for being patient while I had my brief coughing fits here. But this was a lot of fun, and I will post a video as soon as we're done here with the PFG Live. Robin, you are never a troll here, ever. You're an excellent teacher, and I appreciate you very much. Hey, if there were no trolls, this would not be the PFG Live, right? We depend on the trolls. We encourage the trolls, and I'm very appreciative. So who knows? If I could find a couple more, if I could find more stock in my shop, I may make 2 more of these and do this. I will point out that I did, in fact, calibrate. You're gonna hate me for this. I did calibrate my new square to this cylinder square before I came up here. So that was the last thing I did in the shop. And it has these very convenient micrometer adjustments right here. In fact, I found that I had to do it by hand very, very carefully. And this is calibrated. This came out really nice. All right, guys. Let's go down our checklist. Let's make sure we did it. If you guys have any questions on any topic, put it in the chat now. We'll see if we can get to them. There is a PFG Live coming up next week. I don't see any impediments to it. No topics have been selected, but we welcome you, and we'll keep everybody posted on the progress of various projects that are going on. Once again, check out Laney Machine Tech. His Fizzo interferometer is coming along great. And I'm kind of, I'm not going to lie, I'm kind of interested in what's going on there. And in the absence of any more questions or topics, we're going to close this up. And I want to thank you for coming. And Mr. Blodgett says, is cellulose foam less heat sensitive than tool steel? Absolutely is. In fact, it's a very good insulator, so it is less affected by body heat. Thank you for asking. I appreciate that. Sleeping Saloon says, since there is no perfect cylinder, I'm curious if there's a clever compensation method for a traffic cone square. I'm going to have to sleep on that one. Yeah, I'm going to have to sleep on that. Well, you will notice that this version of the square, while it is not a cylinder square, does have all sorts of compensation adjustments, right? Yes, it does. MAB Machine says that the cellulose version is not heat sensitive, but very moisture sensitive. That is true. Robert Simpson asks, did I lap the screw threads? Yes, I did. In fact, first, I took a box of the screws and I picked out, good matches. So they matched each other. And then I proceeded to lap it down to 0.5 micron with diamond slurry, as Robin taught me. So, okay, Robin said troll mode off, and I will point out that that was a little premature, wouldn't you say? I think so. All right, guys, we'll see you next Sunday. We're done with this time change nonsense, so we'll see what happens. I don't have a plan for next Sunday, but that's what makes this great. Thanks for being here. Kenny Eaton throws a grenade by saying, what gets finished first, Rob Wren's surface plate or Tom Lipton's press? I'm sorry, I don't have time to address this. So we'll see you guys next week. Thanks for being here. Take care.